Hello and welcome to another Flux tutorial. In this video, we're going to cover how to migrate from Upverter to Flux. So follow along. After creating your Flux account, you'll be directed to your profile page. In this page, you'll initially find the list of periodic examples that showcase some of Flux key features. Feel free to open and play around with them. When you start creating more projects or some other users in Flux share projects with you, this list will get populated by all those projects. Eventually, it will become your own portfolio of projects that you can then share just by clicking and copying and pasting the URL. To get started, you can either create a new blank project or get inspired by some of the many community projects. To access community projects, you can use the Featured Projects page, which is the curated list of projects, or you can use the global search bar. In the search bar, you'll also find other users and parts. To find specific projects, you can use the hashtag project or hashtag template. That will allow you to find finished projects or templates for your new project. Once you found an interesting project, all you have to do is clone the project. That will create a copy in your projects list that you can modify. Once it's done cloning, you can now have full edit access to your project, meaning you can add, modify, or delete parts. To add a new part, you can use the library on the left side. Libraries in Flux work a little bit different than they work in Upverter. For starter, you only have one unified library, meaning that every part that you have access to will show up in this library. That includes parts that you own or you created, or parts that are public or that some other user shared with you. To search for a part, simply type part of the part name, description, or manufacturer part number in the library, and you can use the filters here to filter for a specific part. For example, you can find parts that contain footprints or 3D models or both. Once you find the part, simply click and drag it to the canvas. There might be cases where you don't find the part that you're looking for. In that case, you can add the part yourself. To do that, you have a few options. The first and simplest option is to find a part from the same family. For example, if you type STM32, you can find parts that are similar to the part that you're looking for, but might have a different manufacturer part number or a different property. In that case, you can open the part, cloning as we did with the project, and then modify a few properties, and you have a part. If you don't find any similar parts in the library, you can also import parts. If you go to the Flux menu, Import, you can import KiCad parts. That includes full libraries for individual parts. Finally, if none of those are options, you'll need to create your own part from scratch. We won't cover the full details of how to create a part from scratch in Flux, but we've added another video in the description if you want to take a look. What we will cover though is a few differences between Flux and Upverter that you absolutely need to know about. The first difference that you'll notice is that parts and projects are created within the same UI. There is no different UI to create parts. That has some profound implications that we need to cover. Everything starts with a project. So let's use this blank project as an example. To create a part, we just need to add terminals, one for every pin that our part has. For example, in this case, we're going to use 3 pins like a transistor has. We can see in the PCB view that each terminal consists of one pad that you'll need to modify to create your own part. But if you notice here on the top right, this is still a project, it's not a part. So if I copy the part name and look it in the library, I won't find it. To find this part in the library, what I need to do is publish it. As soon as I publish a project to the library, it's not a project anymore. It's something else, in this case a part. Now if I type the name again of the part in our new project, you can see that this part is part of the library now, and you can connect it to anything else. But we can even go further. Nothing prevents us from being able to drag a part into our project here, and you can even connect the part to the terminals. What that means is that in our PCB editor, we now have a part and also a few paths. You can keep going. Now what happens if we publish the changes to the library, this part is not a part anymore. It's a sublayout now. Here we have the update to the part, we click on update, and then if we go to the PCB, you can see that our part is now a complete layout. In Flux, we call these sublayouts. And they're a very powerful way of reusing circuits that might be present in many different forms. For example, we can find the USB-C sublayout. You can use a filter here in the top left to filter specifically for sublayouts. If we drag this one into the canvas, you can see that we now have a full USB with built-in regulators. Sublayouts are the reason why you see different things between what you see in the schematic and what you see when you place the part into a project. In this case, you're seeing the part symbol. Here, you're seeing the part schematic. This makes more sense when you're talking about sublayouts, because the internal schematic of a sublayout is completely different from what you see on the symbol. Parts and sublayouts can also have custom symbols. Flux by default creates a standard square symbol like an IC, but you can also have custom symbols imported. We won't cover that into detail here, but we've linked a video down in the description. Just as an example, we can find a part here called an op-amp that has a custom symbol. In this case, when we open the part, we'll see that the symbol here is a custom one. Now that we know how parts work, let's go back to the original project. To create new nets, simply click on the pins here and drag. Click again to finish routing and hit the escape key to end routing. Flux also offers a way to connect things wirelessly. To do that, grab a net portal from the library, connect it to the net, and rename it. In this case, we're going to use run. You'll see that this trace is now connected to this trace, since both net portals have the same designator. You can do that for any other net. Let's now take a look at the PCB editor. To modify objects, we use something called rules. For example, if you click on the layout object here in the canvas, or if you find it in the objects tree on the left, you'll find that we have object-specific rules. You have one preloaded called size, but you can also add more, like a shape rule. In this case, modifying this rule will modify the object directly. Same thing goes for the layout shape. You can add a circular or even a flux shape. It's also possible to create custom layout shapes. We have another video that we linked in the description where we cover that in more depth. Some rules accept vector inputs, meaning that you can have a different parameter for the x-axis and the y-axis. In this case, we have a single parameter, meaning that the x-axis and the y-axis have the same value. But if you add another parameter, for example 40 and 35, you'll see that you have 40 millimeters for the x-axis and 35 millimeters for the y-axis. Finally, you can create rules that target more than one object at the same time. To do that, we use selector-based rules. For example, in this case, we have a rule that targets every trace under the net called 3v3. You can also add more rules that, for example, target every single net. You can add a layout rule called trace width, and then modify that value. If you still have questions, you can head over to our docs at docs.flux.ai. There you'll find a specific guide about migrating from Upverter to Flux. You'll find some of the other key features in Flux, like sublayouts, version control, or a library of parts. Okay, that's it for today. Have a good day.